Hi everybody. Today we are going to be covering lesson 1.4. I know we're doing the lessons a little out of order. There's a reason for that, so just trust me. Don't forget to do the OMHS content for 1.4. That's also very helpful information in addition to what you're going to get here. Also, after this video, don't forget to do the lesson check and the attendance quiz. All right, so we're going to talk about parts of similar triangles. Okay, and there's different parts that we could see. The first part we're going to talk about here are altitudes, and you may have heard this word before. Altitudes. Okay. An altitude in a triangle is what we have been calling the height. Okay. It is perpendicular to one side and touches the vertex of the opposite side. So in this case, BD is my altitude, and FH is my altitude. If you have altitudes in your similar triangles, then you have some proportions that you can set up. I can say that BD corresponds to FH, which will be proportional to, we could say, AB and EH. Okay. Or EF, not H, silly me. So the altitudes can be proportional. Okay. Another type of line that you might see in your similar triangles are the angle bisectors, and we talked about this last class. I know they're angle bisectors because it's cutting angle Q into 2 equal parts, and over here it's cutting angle U into 2 equal parts. And if these triangles are similar, then we've got some other proportions we can set up. We can say that this angle bisector is proportional to this one. So I can say that QS over UW would be equal to, we could say QP over UT. Okay. One of the sides. The other type of line that you might see in similar triangles here are called medians. A median connects the midpoint of one side to the opposite vertex. So this is, J is a midpoint because GJ and JI are congruent. N is a midpoint because KN and NM are congruent. And when those midpoints connect that opposite vertice, I call that a median. When you have similar triangles, the medians will be proportional. So I can say that HJ over LN would be equal to, we'll say GH over KL. So notice that it's proportional to one of the sides that it's not touching. So here, HJ over LN can be proportional to GH over KL. So let's practice using those. We're going to set up our proportion and solve. One thing that is important is that these triangles are similar. If these triangles weren't similar, this wouldn't be helpful. But because it tells us that the triangles are similar, we can set up some proportions. In this example, we have medians because W is a midpoint of TU and W is connected to S. F is a midpoint of CE and F is connected to D. So I've got some medians. So the medians will be proportional. So I can say X over 15, the median from the first triangle over the median from the second triangle. And then we can pick one of the sides that aren't touching the median. So here I could say 16. Well, what does 16 correspond to? This is where the names come in handy. TS corresponds to ED. So I would pick the ED side 20. Okay, so if you're not sure which one corresponds to what, does 16 correspond to 20? Does 16 correspond to 24? You can always look at the name, and that should help. Another way that I could have figured that out, 16 is smaller than 19.2, and 20 is smaller than 24. So the small will have to correspond to the small, and the larger one will correspond to the larger one. Once you have that set up, then we just cross multiply like we've been doing, and we're getting pretty good at it. So 20 times X will equal 15 times 16, which is 240. Divide by 20, x equals 12. Wonderful. Okay. In number 2, we have some altitudes, but the idea will be the same. Go ahead and try this one. Set up your proportion and solve for x. Okay, so you should have gotten 17.5. If you did not get 17.5, go ahead and pause the video and check out the work that I showed and see if you can find your mistake. If you can't, make a note of that to ask during office hours. If you set up your proportion slightly differently than mine, but when you cross multiplied, we got the same equation, that's perfectly fine. Okay, here's some more practice. So they tell me that triangle ABC is similar to triangle EGF. And here in this case, I have angle bisectors. I know that because these angles are being cut in half. So I can say that this angle bisector corresponds to this one. So 32 over 24, which means that 38 will correspond to x. Notice that when I start in this triangle, these are the numbers that will go on top, and these are the numbers that will go on the bottom. You don't want to get them flip-flopped. If you flip-flop them, cross-multiplying will give you the wrong answer. So whatever you start with, so I start in this triangle, and I go to this triangle. Then I go back to this triangle for the top, and pull a number from this triangle from the bottom to cross-multiply. So I get 32x equals, and then we'll do 24 times 38, 912. Divide both sides by 32, we get 28.5. Sometimes, remember, our height or altitude are on the outside of the triangle, and that's okay. The idea is still the same. The heights will still be proportional to sides of our similar triangles. So go ahead and try number 4. Okay, so we know that 12 and 15 correspond to one another, and x and 42 correspond to one another. When we cross multiply, we get 15x equals 504, giving us x equals 33.6. Now, of course, we might see these with expressions. The idea is the same. It's just a few extra algebra steps. In these triangles, we have medians because we have our midpoint of a side connected to the opposite vertex. And we know that medians are proportional. So I know that 20 is the median here and 12 is the median here. So I'll set up a ratio with those. So 2x minus 9 is the side from the first triangle, and x minus 2 is the side from the second triangle. I'm going to put parentheses around those right away so that when I cross multiply, I don't forget to distribute. Okay. Once I have that cross multiplied, I'm going to distribute my 20, and I'll distribute my 12. And now we're going to solve for x. I'm going to subtract 20x from both sides. Negative 40 equals 4x minus 108. Add 108 to both sides. We get 68 equals 4x. Divide by 4. So our final answer, x equals 17. And I could take that 17 and plug it back in and make sure that that fraction does indeed equal 20/12. Okay, let's see. Okay, so we already talked about the triangle angle bisector theorem in the last lesson, so we don't need to talk about that again. You are welcome to review that, pause it again if you need a review of that. I know this was short. I hope you don't mind. But today's attendance word is bisector. A bisector in a triangle splits a triangle proportionally. Bisector. Please spell that correctly on the attendance quiz. I know these feel short, but they are definitely worth practicing. So with your additional time here today, I highly recommend making sure that you complete the OMHS content for 1.4. If you have any questions whatsoever, please write them down and take them to office hours to ask. You have lots of opportunities to get extra help, so I hope that you are taking advantage of those. Have a lovely day, everyone.